Limit theorem. Theorem 1 is the limit of a constant, and the limit of the constant is itself. Another example is limit of 8 as x approaches 3 is equals to 8. Limit of 6 as x approaches to 1 is equals to 6. In Theorem 1, to get your final answer, you just always have to copy the given limit.
Let us now proceed to the theorem number 2. The theorem number 2 is defined as the limit of x as x approaches to c is equal to c and sometimes can be called the substitution law. The substitution law states that x is simply substituted by the value of c. For example number 1, we have here the limit of x is equals to 7. We can see that the value of the c is 7. Therefore, the answer is the limit of x as x approaches to 7 is equals to 7. Moving on to the example number 2, we have the limit of x as x approaches to 11. It states here that the value of c is 11. Therefore, the limit of x as x approaches to 11 is 11. Let's now proceed to the theorem number 3.
The theorem number 3 will be the constant multiple theorem. So, the limit of k times the function of x as x approaches to c is equals to k times the limit of the function of x as x approaches to c is equals to k times l. For example, the limit of 9x as x approaches to 7. The first thing we will do is we will move the constant on the left side. So, 9 times the limit of the x approaches to 7. So, using the theorem number 2, the answer in this one will be 7. Let's evaluate. 9 times 7 is equals to 63. Example number 2. Limit of 6x as x approaches to 8. The first thing we will do is we will move the constant on the left side. So, 6 times the limit of x as x approaches to 8. So, using the theorem number 2, the answer on this one will be 8. Let's evaluate. 6 times 8 is equals to 48.
Limits of Theorem 4, the addition theorem. Now, I'm going to give example of limits of Theorem 4, limits of 3x plus 1 as x approaches to 2. We're going to use Theorem 3, limit of 3x as x approaches to 2, plus we're going to use limit of Theorem 1, now limit of 1 as x approaches to 2. Now we are going to use limits of Theorem 2 as 3 times limit of x as x approaches to 2 plus 1. Now 3 times 2 equals 6 plus 1 equals 7.
Theorem number 5, the multiple rule. The example of multiple rule is the limit of x open parenthesis 3x plus 1 close parenthesis x approaches to 2. So the first step is sub the x to the value of 2 and make them both separate. So the first step is 2 open parenthesis 3 the limit of x close parenthesis x approaches to 2 plus limit of 1 x approaches to 2. So the next step is 2 open parenthesis 3 times 2 plus 1 close parenthesis, and then the next step is 2 open parenthesis 6 plus 1 close parenthesis, then the next step is 2 times 7 equals to 14.
Now we'll dive into limit theorem number 6. The given is lim x squared plus 3x over x and x approaches to 0. Now we substitute x into 0 and it will become 0 squared plus 3 times 0 over 0 is equals to 0 over 0. We have 0 over 0 indicating an indeterminate form. To resolve it, we need to apply L'Hospital rules. L'Hospital rule states that if we have indeterminate form of 0 over 0, then the limit of the quotient of two functions is equal to the limit of the quotient of their derivatives. Here, we differentiate the numerator and the denominator separately. Lim d over dx x squared plus 3x x approaches to 0, and lim d over dx x and x approaches to 0. And it will become 2x plus 3 over 1 and x approaches to 0 is equals 3. So the limit is 3.
Limit theorem number 7. Power rule. The theorem states that the limit of an integer power p of a function is just that the power of the limit of the function. Example, limit of 3x cubed plus 6x squared as x approaches to 2. Then you need to separate the two limits, which is limit 3x cubed plus 6x squared. First, the limit 3x cubed. Limit 3x cubed as x approaches to 2. The first is limit 3x cubed. Limit 3x cubed as x approaches to 2. The first thing you need to do is bring out the 3 outside the parenthesis, then times the limit x as x approaches to 2 cubed. And you will cancel the limit x and the other x. Then 3 times 2 cubed, which is 2 raised to 3 is 8. Then 3 times 8 is equal to 24. Let's go to the next one, which is limit 6x squared as x approaches to 2. Just like what we did on the other limit, you need to bring out the 6, which is 6 times limit of x as x approaches to 2 squared. Then cancel, then 6 times 2 squared. Then you need to square the 2, which is 4. Then 6 times 4 is 24. Then 24 plus 24 is 48. Let's go to the next example. Limit 2x raised to the power 4 as x approaches to 2. Just like what we did in the first example, you need to bring out the 2 outside, then 2 times limit x as x approaches to 2 raised to the power 4. And you need to cancel the limit x and the other x. Then 2 times 2 raised to the power 4, which is 2 raised to the power 4 is 16. Then 2 times 16 is 32.
Theorem number 8, radical root theorem. The example of radical root theorem is limit square root open parenthesis x minus 4 close parenthesis x approaches to 8. The first step is put the limit inside of the square root. So square root of limit open parenthesis x minus 4 close parenthesis x approaches to 8. Then the next step is make separate the limit open parenthesis x minus 4 close parenthesis. So square root of limit x approaches to 8 minus limit 4 x approaches to 8. The next step is get the 8 and 4. So equals to square root of 8 minus 4. That is square root of 4. Then the square root of 4 is 2. Other example is limit square root of open parenthesis x minus 3 close parenthesis x approaches to 12. So the first step is to put the limit inside the square root. So square root of limit x minus 3 x approaches to 12 equals to, then the next step is square root of limit x approaches to 12 minus limit 3 x approaches to 12. So the next step is get the 12 and 3. So the square root of 12 minus 3 is 9 and the square root of 9 is 3.